Today we're going to work on lesson 1.7 where we are looking at representing functions as rules and tables. We're also going to look at how to use a mapping diagram and also to determine if a graph or a table is a function and why it may or may not be. So the first thing we want to look at is our input and our output table. Yesterday we looked at the t-table where all of the x values, all of the numbers in the input column, the x values, those are known as our domain. So if we're looking at this t-table here where the input is 2, 3, and 4, we would say that our domain on this table is 2, 3, and 4. We would just list those numbers out. Now, if our output is 4, 7, and 10, we would say that our range for this is just simply those specific numbers, 4, 7, and 10. More specifically today, we're going to look at this table and determine, is this table representing a function? And what we need to know is if each input has exactly one output. So the first thing you're going to ask yourself is, was anything repeated in the x column? If there are no repeats, then yes, it's a function. But what matters is if there is something that's repeated, is the output exactly the same every time it's repeated? And I'll show you exactly what I mean here. So now we have a new table here where the input values are 2, 3, and 3. And what you may notice is that the 3 is repeated, which is okay. If the 3 is repeated though, was the output the same both times? Because if you put a 3 in, you should get the exact same answer out every single time. And what we're going to notice here is one time we got a 6 out, but another time we put a 3 in, we got a 7 out. So this is not a function. That is not okay. However, if you had a 3 in there twice, but the output was the same both times, so let's say that it's 6 and then it's 6 again, then that would be okay because the output produced was the exact same number both times. Another thing that we're going to look at today is what a mapping diagram is. A mapping diagram is another way to put the same information that's in a table, but in a mapping diagram instead. So what you see here is you have your domain values and you have your range values. But this time we're using arrows. So let's use the domain and call this would be our X if we were thinking about a table, and this would be our Y. Now every time 6 is inputted, you can see here that it results in an answer of -5. When a 3 is inputted, it results as a -2. So it draws an arrow to that specific answer rather than just being straight across from it. Now the one thing you want to look for again in a mapping diagram is very similar to that as a table that we used here. Was any of the inputs, were any of the domain values repeated? So we look here, we have a 6, a 3, a 0, a -1, and a 14. There is nothing repeated, so then yes, this is a function. Now if there is a repeat, that can be okay, but did it produce the same answer? So let's look at another mapping diagram. In this example, you can see that our input values are 10, 20, 30, and 40. So again, the first thing we're looking for were any of the input values repeated. Well, none of the input values were repeated because they're all 4 different. We have a 10, we have a 20, we have a 30, and we have a 40. Now, when I input the 10, we output a 15. So that ordered pair, if we're thinking as ordered pairs, would be 10, 15. Our next one would be 20, and that resulted in an answer of 45. So our ordered pair would be 20, 45. And then we would have 30, 25, and we would also have 40, 35. So as you can see here, none of the x values, none of the first numbers were ever repeated. So again, yes, this is a function. Now let's take a close look at what is a function versus what is not a function. So in this, we have 2 different diagrams. Our first one is our mapping diagram where our input, our x values are 2, 3, 5, and 7. And then every single time we have a line drawn from the input to the output. So what you can see here is each input value has one output value. Nothing was repeated in the input column. Now on the second one, this is not a function because when you look at the number 2 here, you can see that one time it produces the answer of number 4. Then it gives you a 6. Then it gives you a 10. That can't happen. A 2 can be repeated, but the output has to be the exact same every single time. And we have 3 different outputs. So this means that there's more than one output value, which means that it is not a function, rather it is a relation. We're also going to look at our coordinate planes. Yesterday you started to graph functions by plotting those points given a domain and a range. So when we look at this graph on the left, you can see that one of our x values, so if we were to list out all of our ordered pairs, we would have the ordered pairs 1, 1, we would have 1, 2, we would have 2, 0, we would have 3, 1, and we would have 4, 2. Well, what you might notice right away is an input was repeated. We have 2 input values, 2 x values of 1, and one of those times it produced the number 1, but then the second time it produced the number 2. So in this case, this is not a function because the input has more than one output value. It has a 1 and a 2, which means it can't be a function, it is a relation. Now the other thing, we can still identify what the domain is. So the domain is all of the x values that are listed. So if you look at all of our ordered pairs here, the domain values that were used were a 1. We used another 1, but you don't have to repeat it. You only have to write the 1 once. We have a 2, we have a 3, and we have a 4. Now the range, it would be all of the y values. So we have a 1, we have a 2, we have a 0, and then we have a 1 and a 2 again. So again, you don't have to repeat. So no, this is not a function because the input was repeated, but it produced separate answers. Now let's go ahead and take a look at the graph on the right. So here, if you were to list out all of the ordered pairs, here you would have 1, 3, 2, 1, 3, -1, 4, 2, 5, 0, and 6, 6. There are no input values, no x values repeated, so yes, this is a function. Now the domain would be all of your x values, so we would list out 1, 2, 3, 4, 5, and 6. And then all of our range values would be those specific numbers for a range, which would be 3, we would have a 1, we would have a -1, we would have a 2, we would have a 0, and we would have a 6. So yes, this is a function, and you have your domain values listed, your range values listed. If it's easier for you, list out all of your ordered pairs or make a table of your values, of your x and your y values, if it's easier for you to identify the domain and the range that way. Now there's times where you have a continuous graph where you graph a line. And what we can do here is we can do something called the vertical line test. And the vertical line test tells you, go ahead and make a straight line, a vertical line going up and down anywhere you want on the graph. So you can see here, I can make a straight line right there. Now the vertical line test tells you if your graph intersects your vertical line one time and only one time, then yes, it's a function. So on this first one here, we would say yes, that's a function because the vertical line test tells us that it intersects one time, so that would be okay. Now if I were to do a vertical line test here on this one, you can see that this one intersects 2 times. Well, the vertical line test tells you one time and only one time, so this would not be a function. We can go ahead and check this one here with the circle, and this one too intersects 2 times, so because it intersects 2 times, it is not a function. Now, in all 3 of these graphs, we can still identify the domain and range, but these are not just points on a graph, these are continuous lines. So the domain and the range need to be written as an inequality or as a compound inequality. So when we look at the first one here that I'm circling, what are all of the x values? Well, x goes all the way to the left because you can see that this is continuing on forever and ever, and it also goes all the way to the right, so that goes on forever and ever. So our domain values here are infinite numbers. It includes all numbers. So you would write domain as infinite, okay? Now the y values, the range, the lowest value here is 0, and it does touch 0. So we would write this as an inequality, but we're going to use the variable y because it's considered our y value, and our y value is greater than or equal to 0. The lowest part on there is at the x-axis, which is at 0. Now, if we look at the next one with our domain and our range, we look at this graph right here, you can see that the x value on our line, the lowest part is -4. So we would say our domain is x is greater than or equal to -4. But those arrows show that they're going to continue on forever and ever. So that our x values are going to go, they can go to 5 or 6 or 26, or they can continue on forever. Now our range values, our high and our low, you can see that this continues to get lower and lower and lower, and this continues to get higher and higher. That's going to continue that route, so it includes all numbers. So we need to either write infinite numbers, or you can write all real numbers as far as your range goes. The last thing I want to touch on is a rule. When you're making a function rule, which you're going to be doing in the next day or two, is all of the independent variables are your input. So I can make all these x values and they don't depend on what y is. I can just make up those numbers. They're independent. But the y values, the output values, depend on the function rule. So I cannot get an answer of y without the x value. So that's something that we're going to look at in the next day or two on how you can make a rule based on a table or based on a graph. But right now I want your focus to be on your mapping diagrams, identifying the domain or the range, and then also looking at those tables that we talked about.